You probably didn't mute your YouTube, would be my guess. That might be possible. I mean, feedback to me sounds more like you can hear something double or something, which you shouldn't. Yeah, the background is normal.
You can have other libraries produce this. So for example, like if you were using System HTTP JSON, how can you have it produce the post request or the send request, but also use options that the user would want to say, like things like cache or integrity checks, or like including like credentials and so on and so forth. So I basically listed like 3 options that I thought were interesting. So one was like specifying cache. The second was like specifying an integrity check. And the third one was like to figure out if credentials need to be included when you are sending, when you're making a fetch request. And my proposal was it's something that we went over the last time we spoke about this, which was adding some sort of bag to the HTTP request. And then this was based on Corey's proposal for some other API, which was like basically that this was a more strongly typed dictionary property bag of sorts. And so you weren't getting loose strings, you were getting like typed values back out of things. So like it had some level of typing to it. And then I have some examples of like how you might possibly use this.
So let me just scroll down, I guess, to the to the API proposal here. Okay, so
I'm a little confused. Isn't the one that we were looking at on like Thursday and we said we needed the networking team to review first? Or is that different?
no, that was the one, but I tagged Corey to take a look at this on Thursday, and I invited him to this meeting. That was the idea.
Right, but it doesn't look like Corey marked it back as ready for review. It still says suggestion.
He did not. I mean, the idea was if he had opinions, my hope was that he was voicing it here as well, but yeah. Well, that sucks.
Because we'll have the same questions we had last time, which is the interface needed? Can this be unified with what the proposal is for?
I mean, I guess we can
stuff.
still ask those questions here, right? I mean, so given that Pranav is here, he probably has an opinion on this. So, like, is there any reason why it can't be just a type? Like, why do you need the abstraction?
Just the HTTP request options.
Yeah.
I think I basically like tailored this based on the other issue, and so I thought there was like some history as to why the interface was chosen and why like there was an abstract implementation to it. But I think like the idea was like the interface was immutable. So once constructed, like you were supposed to like treat it as immutable versus the concrete type of something that you created and passed. So you had control over like or adding it. And then like obviously like if you as a consumer wanted to, if you as a library author wanted to like add merge semantics to it, like you sort of control its destiny rather than us determining how that would be.
Yeah, that's what we thought last time. The problem with that is that people can cast it away, right? So if you expose the HTTP request option somewhere and you actually just basically under the cover just hold it as an HTTP request options thing, then people can cast it and then still add stuff to it, right? So if the immutability aspect is important, then you probably need a decent internal implementation of this somehow that people can't cast away, which I think generally speaking will probably defeat the purpose. Another option is to literally have HTTP request options, the type you can freeze effectively, right? Where you can just say, okay, now you can no longer modify it, and then if people call add on it, it just throws an exception.
Right. We could switch it over to a builder pattern if like that was important. But like I'm not strongly married to the idea of like having an interface and a thing. It just seemed like, you know, you wouldn't want to pass in a mutable thing to like the actual HTTP client. Yeah,
I mean, my default assumption is that when API requests come from ASP.NET, they usually start with interfaces because that's kind of like the, I don't know, aesthetic or style choice for most of the functionality in ASP.NET, and that's okay. But like when we BCLified, we have to think about that and make sure that we don't just have interfaces for, you know, stylistic reasons, but they're actually meaningful, and then also whether we can convert some of them to abstract base types because they usually version better than interfaces. And if we don't need abstractions at all, that's even better because that's one less extension point to having to support. I think that would probably be the number one feedback item. The other things, I gave it a quick read. I mean, they look reasonable given the other existing APIs we have, including the extension method for the JSON stuff. I mean, it certainly seems more closer to what we want this to look like based on the initial discussion we had. So maybe we should just end it here. Like, you know, maybe drill into the interface again and see whether we actually need this and whether immutability is important there, and then maybe convert it to a builder or just a freezable type, and then let Corey respond to that, and then we can take another look. I don't know, Thursday, whenever the networking team actually took a look at it.
Yeah, I mean, to me, just getting rid of the interface seems fine. Like, drop all the I's and it looks reasonable. I mean, it doesn't, like, yeah, okay, so delete async has an object that is theoretically mutable, but it's probably not going to mutate it, and it, as the interface, it wouldn't modify or wouldn't matter anyway. And yeah, so I just don't think the interface is adding anything. I'm also not sure if we actually want to do the complicated structured options on this one, as opposed, like, everything that I saw looked like it was just HTTP headers. So it seems like you just want an extra headers collection. If it's more complicated than that, then sure. But we're gonna have the same problem on this one that we were talking about with the system.net connections one, which is how does someone know what keys and such to use? If it's just headers, that's easy. It's headers. They're public.
So at least in this case, there was like this one like odd scenario where you didn't want to send like more than like a header value. It was like a Boolean value that configured how the HTTP response was being read, and I think that's listed like up there. So I mean, it's something that the HTTP client and WebAssembly already does. So it's not something that, like, I'm not saying that it is correct or like that's the best way to go about it. It was just like, if we had that feature and we had to use this as a way to configure it, like, you know, the having a named option would, like, or having a strongly tagged option kind of helps there. The headers do like I guess like libraries that care about the headers would like or these options would have like static types that expose them. So, you know, so you would have like a browser request options or something like that that would have like all of these keys in there. So, and then, you know, they'll specifically look for it, and it kind of makes it easy for a user to use it and for the library to consume it on the other end.
One other thing to keep in mind as we're reviewing or revising this is these objects are already heavier weight than we would like. Like HTTP request message already has, you know, we've been trying to trim it down. We've been trying to play internal tricks to reduce state, and we'll probably still continue to try and do more. So anything that increases the size is a little concerning, just because we're using these more and more in situations where we actually care about, as much throughput as we can get.
What would be the way to address it? Like if we do want to introduce like a first-class API in addition to this, like just, I mean, you can obviously
one thing would be,
sorry, go ahead.
one option would be to, just as an example, I'm not sure we should do this, but if it was purely a wrapper around the existing non-strongly typed properties, then we would basically just be reusing the existing thing and it'd be pay for play. There's already a field for that properties, or maybe we reuse that field and we do something where if you just use one or the other, you get to use that field and we cast it to the appropriate thing. And if you use both, well, then you pay for that and we allocate some new object to store both. There's something along those lines, because properties isn't very commonly used. So it's just something to keep in mind. I'm not saying it's a deal breaker. It's just, I want to limit how much more state we shove into these things by default.
So for the 3.2 release, like just because Blazor didn't require shipping some of these APIs, like we ended up using like the property bag, and like a bunch of like private, like a a well-known key that the Blazor implementation and the WebAssembly implementation knew about, and using that works kind of well enough. But then I don't know how well it scales for like an arbitrarily large number of libraries trying to like work on it.
Sure. Yeah, I'm not saying I'm against the strongly typed thing. I'm just saying if we can find a way to not grow the state by default, that would be great. So that might be that we change the existing field from the collection that it is to an object, and we allow it to store either the strongly typed or the non-strongly typed. We only bloat if you have both. It may be that we store the strongly typed inside the non-strongly typed, or we can play various tricks. But it'd be great to think through the design, the implementation as we're thinking through the design, just to avoid adding more overhead for scenarios like being used in a reverse proxy, or folks that are trying to kind of just get as much throughput as they can using HTTP client.
So what I'm hearing then is it is what it is.
I didn't understand that, but
it's back to the questions that we.
So I guess we can focus on the like what the abstraction would look like to configure it, because like I don't hear anything, anyone saying specifically if like adding the extra parameter to like all of these methods is problematic. It's just how do we actually expose it?
I mean, I don't think there's any way that we can get good per request things without adding the members, so that seems fine. To say again, I don't know that the interface is buying anything over just having the type, and then Steve's is about implementation, which I think all his comments could be done with the shape as suggested here.
I mean, it is a bit of a how should we say?
I didn't quite follow why we would have to add all those individual overloads. If this is all sort of more advanced stuff, and it can be achieved if you had the one property on the HTTP request message, for folks that do want to tweak these per operation things, they can't just use the overload that takes an HTTP request message?
So if you scroll down, there's a scenario where if you were trying to like have, for example, something else produce it, but then before it sends the request, like something else produces the HTTP request message for you or the HTTP content for you, and you want to assign this on top of it. So I guess
why can't you just, if someone hands you the HTTP request message, you can modify it?
Yeah,
if the request options is public, you can just call add and add the options that you want.
I think the scenario that he has in mind is more like the HTTP extension methods one, where you'd never see the message, right? The extension methods directly create the options and immediately send it off. So this is an example where you basically would change the get from JSON async extension method to take a request options, because otherwise you would have to do everything by hand. But that doesn't necessarily imply that we need to have delete async and get async and send async, right?
Right. So the extension method that's based on, URI and such. Obviously, the input would need to come from somewhere, but if we think that this is advanced and somebody who wants to do it is already building a request message, then that does mean we can drop all of the modifications to HTTP client and just add it to the JSON extensions and then the one property on HTTP request message.
I'm not entirely sure. Like last time I looked, it seems like there's still somewhat of a steep fall off though. If you like convenient wise, I'm not sure that's what we want in all cases.
Yeah, I mean that's sort of my recollection as well. But then it makes me wonder if that just means that all of the places that we think that the existing like delete async, taking a URI is easy, but building a message is hard, that we need to just make building messages easier.
Yeah, maybe. I mean, it certainly seems concerning, right? Because next time we need to do something else, we again add 12 overloads, right? That seems, not 12, but like 4 or 5.
Yeah, I think the intent of those methods on HTTP client is they're the trivial, super fast, like all you want to do is specify the URL and then, cancellation token. And anything beyond that is you start getting into the realm of you produce an HTTP request message. So then adding in these one-off options for this or that, makes me a little nervous.
Yeah, any thoughts from the HPNet team on this?
At least for WebAssembly, like most of the scenarios probably revolve around sending and receiving JSON. So we'd be happy to have JSON to start with. And then like, if we do end up getting a lot of feedback where, people are trying to like use delete async or something like that, and need to configure these options, we can always add them later on. Like, it's not a.
Yeah, it seems for the WebAssembly scenario, like we probably, so rather than prioritizing delete async, get async, and send async, it seems you're better off prioritizing some extension methods over the options, right? Like the set browser request cache, for example, rather than asking people to go through the generic, add key value pair API. That would probably improve usability more than the other ones.
Sorry, I didn't fully follow this.
So rather than, like, it seems like what we are saying is the delete async, get async, and send async overloads that take request options are not that important right now. But for WebAssembly, what seems more useful is if we have to add extension methods over the request options type to make setting whatever the WASM specific settings are more convenient, so people don't have to go through the generic key value pair API. Because if I go request options.add, like how the heck am I finding browser request options to begin with, right? Like I just have to know that there's another type that holds on to these keys.
Right.
That seems to be more useful for the WASM scenario, at least.
Yep. Yeah, so it sounds like the minimum is the options class, the get from JSON async, and the request options property on the request message.
Right. So, it wouldn't be limited to get from, like it might, like it'll also include like the post and delete. I just didn't list all of them just because there'd be the same pattern.
Sure. So the JSON extension overloads the request options property and the request options class.
Mm-hmm. So
and then
for
wherever the keys come from for the initial supported members.
Right. I guess like send async, you don't necessarily have this problem because you can always configure the HTTP request message if you really need to. Like you have that message.
Messages are only used once, right?
Yep.
Yeah.
Like and this I think like the earlier design where like the type was immutable, or at least like had a semblance of immutability, made it like difficult to configure it. But if you say like it has APIs to like add to it, like that problem is solved. You don't need to explicitly pass another thing to like figure out how to merge, because you just set it on the request message.
Yep.
So just to clarify, you can use request messages multiple times. A lot of people don't, and the fastpat helpers will new one up each time, but you can create a message and send it multiple times.
Right. No, I was saying that like in the in this current iteration, or at least in this API proposal, like the option that the property on HTTP request message was an HTTP request options, which was immutable. Like it only
gotcha.
had a try get, but if you combine them, like that goes away.
So basically, we would just have HTTP request options. We would merge them with the interface, remove the interface, remove the overloads like delete async.
We'd remove all the modifications to HTTP client.
I guess that's true, right?
Because send async takes the message had the options.
Right.
That also removes any notion of a merge policy. So it makes the API easier to reason about.
How do we rationalize how are we thinking about rationalizing the existing properties with the new one? I mean, effectively, we are talking about two different property bags on a message. One is just strongly typed and one's not. Is there a design where we don't add anything to HTTP request message and we just have like if you want to pull one of these out, this is the name that it'll be in, and that you get out your request options from that? I'm just trying to balance, usability for the common case with usability for this, or for the broader case with usability for the Blazor case.
Yeah, I guess my question would be, I mean, in order to, the only reason why we would have to split would be to say, if in cases where you don't construct the message, you basically have another thing that you can pass in, like the JSON case, right? But in the normal case, yeah, there probably isn't a lot of reasons why you would choose the options over the message.
But the properties is already there's already an existing property named properties, which is iDictionary of string to nullable object.
So, you're
right,
saying
that's what I'm referring to.
You're basically asking the generic property bag that we already have. How do we reconcile that with the request options? I see.
It sounds like it's publish some well-known string keys instead of using the type as the key, and
or
we
an
don't use any
intermediate,
new
which
API.
or I mean, there's the middle ground of you still have the interface or whatever, and there's a known key to pull out that from the property bag. So you don't add another property to HTTP request message. You just say, if you want this object, it's going to be living in this property bag. Now that has downsides as well. I'm just trying to think about how there's now two different things, and neither of the two shall meet. And it feels, just walking up to the API, it feels weird.
I mean, the unfortunate thing is we decided to make the property bag generic, right? So as iDictionary of string comma object, so it's very weird to pass that around. And it makes it almost impossible for us to add extension methods over it. I mean, we could, but we generally don't like doing that, right? So I guess one takeaway for me would be every time we add a property back, we should have a very specific type for that and not some,
Well,
generic collection type.
But we can add, set cache option, which just uses a well-known key and sets the thing, and get cache option, which just does the try get value on the well-known key. Like the fact that we have string object, like it doesn't really change anything other than there's, if somebody uses the same key and shoves the wrong kind of thing in it, but
right. I guess
true anyway.
I guess my point is that I think the way it's designed right now is if we want to add a strongly typed helper for a request option, we can just define an extension method over HTTP request options, or even add the API directly onto HTTP request options, right? That option doesn't quite exist for an iDictionary of string comma object, right? That's kind of, I think, where the problem is.
I mean, given either the question Steve asked or the question that appeared in my head after I was following up on what Steve was asking is, we already have a per request properties,
right,
which is an open-ended property bag keyed by string. We don't need another one. Like, we just need to define more keys and what they mean.
I guess my question is, so that's fine if you talk about the HTTP message directly, right? That falls a little bit apart when you have things like the JSON API, where you want to get the options in as an argument.
Okay. That's
well, unless you do the middle ground, which is you still have the request options thing, and that can be stored into the properties.
Yeah, I mean, one thing we could consider is having the request options implement iDictionary of string comma object, and then just make the properties itself settable on the message, and then the semantics are whoever constructs the message just assigns the property back, and then it's literally the same thing.
That's not unreasonable.
Yeah.
In fact, we could go a step further and say this property that we currently have, we leave it as is. We mark it editor browsable never. We add a new property on message, options, make that strongly typed, and make the properties effectively just return this guy. Then we have literally one storage. The new thing is get, set, and strongly typed. And that should solve most of the problems then.
Yeah, that seems like a decent idea.
Let me try to sketch this here in the editor.
Yeah,
are you projecting email?
I am sort of projecting, but it's via YouTube, so it's it's a massive latency projection.
Right.
But how can you see this, Steve? Aren't you walking around somewhere?
I am. I'm looking at my screen.
Oh, you're looking at your phone. I see.
I'm incredibly safe. But it also means that switching between Teams and the browser and then YouTube is not the ideal experience.
I can see that.
This is possibly a terrible idea, but I will try to help Steve out by I will share YouTube.
Actually, that's not a bad idea.
Don't worry about it. I'll be at my computer soon. That actually worked pretty decently. I've never doubted you, Jeremy.
Yeah. Ooh, and now YouTube sees YouTube, which sees YouTube, which sees YouTube.
So let me change the syntax here and zoom in. That's kind of what I was proposing. I guess, strictly speaking.
I'd be willing to bet, and we can look at API's usage to see if I'm right or wrong, but I'm willing to bet that very few call sites actually populate properties.
An API port properties is used by 6% of apps.
Why hide properties? Just
But it's weird having two things that do the same thing.
I know.
Yeah, I guess that's the.
Hiding is so annoying.
Yeah, I wonder if it's just gonna be a bad experience for people as they straddle, or if they straddle versions, or like while upgrading. Like, on the one hand, I see the argument for hiding it. On the other hand, I see one for not hiding it, and then maybe we just mark it obsolete and say you prefer the options instead.
I mean, either one works for me. I mean,
That sounds better.
So what is the downside of hiding it?
Hiding APIs is just like, it just seems like an annoying thing to do, to be honest, like in general.
Sure, but when we're okay with obsoleting it, which creates a warning for everybody, that seems even more annoying.
But at least it signals intent. Hiding it is kind of like a just hidden intent, really, because it still works fine, and there's nothing, and nothing is saying not to use it, and you have and you see it, so you're just very confused as to why it's hidden.
Yeah, I mean, works for me. I mean, in this case, generally speaking, I don't like hiding APIs because when you call them, it gets annoying. But in this case, like, why would you ever use properties if you have options, right? There really isn't the reason. In fact, you can treat options as an iDictionary of string objects. So even if you pass it around,
I mean, technically, so I don't know what uses anything on properties right now, but if it's not following the pattern of using the type name of the value as the key, then you would need to use property still to get legacy support. So that would be why you would bring it. And then obsolete may actually be a little, because if you're in that case, that's the only thing you can do. I guess not, because HTTP request object is a dictionary of string to object. You can call the other add and try that. So take it all
David,
back.
would you mind muting for a minute?
Oh, sorry.
Yeah, so I guess if you're on net 5, because it is the iDictionary of string object, as long as we don't explicitly implement that interface, then just using options would give you everything properties did, including non-matched keys and values.
Right.
So,
I mean, what I like about the design is that it composes very cleanly, right? Basically, the semantics is for things like JSON, you just construct the message, you assign the options directly. If you work with the message, you just work with the options there. It's strongly typed. It can be strongly typed.
Did we make a public try get value extension for iDictionary?
I believe we might have. I think there this collection extensions thing that we have.
Yeah. So in that case, we should, instead of try get of to value, it should be try get value of to value. So we don't have try get and try get value.
So we have try. So which one did you ask for? Try add?
Well, so we have, so as it's proposed right now, the get that uses generic inference, or the generic get is just called try get. But if we made a try get value extension method apply to iDictionary, then that means in IntelliSense you'll have try get and try get value. So I think we should make it try get value and try get value.
I'm still confused. So what are you suggesting exactly?
Rename line 6 from try get to try get value.
Yeah, so this would match the dictionary's try get value.
Ah, I see what you're saying. Okay, that makes sense. So now they're basically overloads.
Right. So one takes a string and the other one takes a to value. Well, an
Yeah.
option key of to value. Where do we define option key?
I might have dropped it from the.
I don't recall seeing it in the proposal.
I don't remember C# overload resolution rules. If there is a generic on the instance and an extension with the concrete type that's being passed in, which wins?
It depends on what the T is usually. Like in this case, the T is bound, right? So the T is bound to string already because that's what you're implementing. So it's basically an overload between string and HTTP request options of the generic from the method, right?
My recollection is if through any kind of it is that the evaluation is first done with no regard to extensions. So if it can work with an instance method, that will always win.
Okay.
Even if it's, even if you had an exact type match on the extension method and something took object on as an instance, the object instance wins, is my recollection.
Okay.
That is also true, yeah. If it can bind on the instance, I would prefer that. So in this case, yeah, where's the request options key coming from? Is it an existing type? I don't think so, right? I think we could design this as a strongly
Yeah.
typed.
I think I missed like adding it to the API review.
But would it be a struct? Probably. It's just a struct based wrapper for a string, right?
Yeah.
And then it basically holds the thing in the actual type, right?
And presumably it's just a type safe reference to the type name.
I guess that's true, yeah.
I assume HTTP request options key of to value just produces a toString, which is to value.fullname.
It just means you can't have two keys with the same type. Not sure you want that, but
Well, I think that's what we were talking about for the connections API, is because essentially that you're just putting in the type as the key and getting back the singleton value as the value.
yeah, it just means if you want to define something that is of type int, you have to kind of define your own struct that just holds an int.
Yep.
Which I'm not sure that's better necessarily, but yeah, that's the implication. Yeah, I guess that would be good to define, right?
Yeah, I mean, I guess one option is that it's struct HTTP request options key of T and it takes a string. And then another one could be the default, which just does the default. So it can just be I'm an arbitrary string wrapper that is carrying a type just for generic inference.
Yeah. Yeah, I mean the generic inference one you get one way or the other, right? But that's
And
more.
the try get value is out to value because it's a get.
I guess that's true. Do we want to try add, or do we not care?
Well, I guess the question is add or is add square bracket?
I mean, if you're deriving from an iDictionary, it better be not.
That's true. Yeah, I also don't know it needs to be builder pattern. Like this add returning this feels weird given that the other one's void.
I agree with that as well.
Yeah, so if we're having an add, then because iDictionary just says use the square bracket for replace syntax, right? There's no named version of the square bracket method. Indexer, that's what we call them. There's no named equivalent of overwrite.
No, there's no replace, I think.
Yeah. So what does
Can I indexer be generic? Like, I think that was maybe why this had to be add.
I can't think of. I don't know it to not be allowed, but maybe it isn't. I guess the problem is the indexer, you want a different. I guess it'd be because it'd be this of.
I mean, it has to be like T-key, and I think I couldn't write the generic constraint onto this.
Yeah. I don't. Yeah, and so that may mean that we need a method named set, which iDictionary doesn't have, but it would just build the string correctly and then use the indexer. But we can't. I mean, we could have triad, which would just be calling try get value, but that makes it. I don't think we would want to do it because it would be more expensive than it looks. It's a double dip method inherently.
Yeah, I mean, I'm not sure that performance is the biggest problem here. It's more like the semantics you want to have, right? Do you want multiple parties to replace, or do you want everybody to basically say if it's already there, I'm not overriding it?
Right. So I think add and try get value, like together, that's triad, because that's all that triad would do is call try get value, and if it's
right.
false, then it would call add. But I think we need set, which if we can't have the generically constrained indexer, then we would need to name the set method on this type.
All because you can't constrain the indexer. That's true.
Right.
I mean, another way we can do it, we can just say we implement iDictionary explicitly everywhere, and we just only expose the APIs we feel we should expose.
I mean, the problem with doing it explicitly is the falling back to existing things where I guess it's because this isn't taking the type as the key, it's taking a random key, so you could build your own key using the right value. So yes, it could just explicitly be iDictionary, I guess.
You can even go a step further and remove the inheritance hierarchy and just add an implicit conversion and return some internal stuff or some private stuff. And have the public API just forward.
I mean, an as method's probably more F# friendly.
I guess that's true too. I mean, we could do both, but yeah. All right, I think that's enough, I guess, in terms of feedback.
Sorry, where did we land on the explicit implementation? Like, was that the recommendation here?
I guess the problem is you need to define like what, like because basically if ICP request options implements an iDictionary, the question is, do you want all the APIs on iDictionary to be in the public surface, right? Like, and this goes back to what I said earlier about what semantics do you have? Because like, what do you want people to assume options? Like how do you want them to work with options? Do you want them to set everything, or do you want them to try everything? And a dictionary is not necessarily communicating that very well, because if you open IntelliSense, you see like the typical dictionary methods, versus in your case, you currently only have two methods. And it's I'm not sure what you intended add to do. If you intended add to behave like a dictionary add, meaning it throws when the key is already set, or did you expect that to be, you know, if it sets it if it's not there and it adds it otherwise. And so I would kind of decide on what the semantics are, and then based on that, you decide the API surface.
It's supposed to be set, we should name it set.
Right.
Yeah, like maybe set would be appropriate here. Like, I don't see like people trying to like build entire pipelines out of this. Is usually like the idea is for you construct something, you pass it on to something else, and then it goes on its way. Like we're not trying to build like pipelines of somebody configures something in method A, it gets passed on, and then like we're not trying to build a whole middleware pipeline here. So maybe just calling it set should suffice for now, and then we do an explicit implementation.
Yeah, I mean that. I think generally we found that explicit implementations end up making something more painful than it should have been eventually, but in this case, it's probably fine.
I mean, keep in mind you can always make explicit things implicit things, right? That's not a breaking change. So
yeah, I mean, I'm just looking and thinking. So we have these strongly typed things, and then we have like contains key string, right? And it does feel like we have a good reason for having the iDictionary of string object here, so that we have compatibility with the existing API, but that really that's a compat detail, not a public detail. So yeah. So yeah, explicit might be better. And as you said, that one we can undo. All right, so the HTTP request options key, is that just a struct that takes a string? So public struct HTTP request options key T wraps one string with a string constructor.
Right. Is there one which generates the key directly from the type? Like
we'd have to use a named static method on it, because
if it's a struct.
Yeah.
Because you can't have parameterless constructors and structs, right?
Yeah, I guess like it's just something that takes a string, and that's about it.
Yeah, I mean, if we expect them to be instantiated once ever, I mean, it would be it could be a class wrapping the string instead of a struct wrapping the string. Gives the default constructor, and yeah, it walks through one more indirection to get there, but that's not the end of the world.
It seems almost like you want string to be always present. Because what do you do when somebody didn't I mean, you could just use the full name, but then
yeah,
you
like
have
the
to be
idea
very
was
sure that you never need another one of that.
I mean, which for a lot of these things might be true, right? Like if you're setting credentials or cache or like all of these options, there's only one of them, and you're always setting them. Like it becomes interesting if you start wanting to send like bools and like more primitive types.
Yeah, I guess that's true. If your types are compound already, then they're probably still in use. I buy that. I mean, in the end, it probably doesn't matter one way or the other, because as Jeremy said, you very likely define a static type somewhere where you define all the keys. So whoever does that, they just pass in either a string directly, which is done by a name of, or they type it out, right? Like it probably doesn't matter. Like even if you were to add a create method, I'm not sure you're typing or you save that many characters. But I don't care one way or the other.
So one small sort of question. So if you happen to cast the request options to a dictionary, and then you shove like a different value in there, and then try to call try get value, like is it fine for it to throw like cast exception?
Yeah, you would reject that. I mean, that's kind of the same thing that happens with arrays, right? When you have an array of customer and then somebody casts it to an array of object and then assigns into it, then you get in. I forgot what the exception is you're getting, but basically you get a type mismatch exception. That would be the same here.
Yeah, I would. Try methods are supposed to have a clear answer of what false means, and so having the try get the strongly or the generic try get value return false if and only if the string when returned false is good, and then if the string when returned true but the type doesn't make sense, then yeah, that's a invalid cast exception. Just hard cast it and let the runtime deal with it.
Okay.
I mean, I would expect the API here to verify that you can't put in an object that doesn't match the key's type.
Well, the set is guarding it from the runtime type system. This is if you turn it into iDictionary of string object, or I guess you can make your own HTTP request options key of cache settings with the correct, I guess if you make it of cache settings, you'll get the, so you make an HTTP request options key of potato, whose toString produces the same one that the one for cache settings would, and then you save a potato. Now, when someone asks for request options key of cache settings, the type is wrong, or the value type is wrong, but the key matched, and so now we have a late bound conversion problem.
I guess that's true because if the dictionary literally holds the strings anyways, then you have no way in the setter to actually verify it.
Right.
That's true. Yeah, I think that's fine. I mean, you can either, I think you probably want to check on taking things out then, which seems fine. It's not great.
Meaning you want false to mean it's not there or it's the wrong type?
No, you can, I mean, all I'm saying is you have to verify one way or the other, and we can either decide that it's a false or we can say it's a throw. I would probably go with throw because to me, try get value means is the thing present, not does it have the right type. And
I agree with that.
Cool.
In particular, it means the two try get values don't disagree on truthiness. Yes, I can use words. All right, so did we make request option key a class so that we can reject null, or is it a struct and default is just very unfortunate? I mean, I think the dictionary is itself going to request null, so the default would presumably toString to null, and then then the underlying dictionary would throw of, hey, wait a minute, I'm not allowed to have null keys. So that seems fine to me. I mean, if you use a default key, you should expect that to not work anyways, right? Fair enough. So I guess, yeah, it can stay a struct. Strongly typed string. Emo, please put the L in the access modifier for HTTP request options so it turns red.
So where you want the L?
Line 17.
Okay, fair enough. I'm glad nobody made the obvious joke.
Yes, I found a polite way of saying it.
All right. Then I think we have enough feedback for this API, which was our fast review, ironically.
Yep.
So I guess we can consider this approved then, and then we can say if Corey has any concerns, he can bump it back. Scalable scoring, right? Yeah. All right. All right, I think at this point we need to be honest because it's 11. I am somewhat skeptical that we will go through ICastableObject entirely. So if you're here for the logger, I would suggest come back Thursday because I don't think this is going to happen. All right, ICastableObject. Aaron, do you want to give us the spiel on what this is?
Yeah, so this is basically a way for types to participate in the cast operation. This technically doesn't really make a lot of sense in most cases because metadata is static, and if the metadata doesn't have the appropriate type, then it's a very simple question. You can't cast to it, or you can. There are scenarios in COM specifically, which is like I don't know, I can't QI for every known GUID. It's just not efficient. So this basically says, well, let's not try to generate all of the RCWs statically. Let's kind of be a little more flexible. So it's kind of like a dynamic interface addition to metadata. It's basically what it is. This concept exists in the .NET Native world, and .NET Native was static RCWs and CCWs, and we're trying to bring some of that slowly into .NET Core. This is kind of an extension of the COM wrappers API that was approved in .NET 5. This is the RCW side of that, so that I don't need to know, if maybe I don't know, at all the types. I have a hidden interface on here that isn't in whatever description of my COM objects, and I want to be able to query if that's really what it comes down to. So
how is this different from ICastableQuery interface? Because it sounds very similar to what you're describing.
That's true. So you do something like that. The downside is that ICastableQuery interface does not participate with a C-style cast in C#. So this allows basically what our built-in RCW and CCW system supports by allowing casting on an object, and that would add an interface, the interface metadata to a type at runtime instead of ahead of time. If you scroll down, there's an example.
So how is this casting support coming? Because C# is not aware of ICastableObject, right?
It is not. That's true. This is a runtime. This is support that could be added and say you've written some sort of object, and if you have implemented ICastableObject, and during the cast, C-style cast in C#, it says, nope, this doesn't exist, and you implement this interface, you have an opportunity to say, I can make that determination at runtime instead of just letting the runtime determine it from the metadata.
So presumably the only valid targets of this are COM types.
That is the canonical example, yes.
Well,
I think
if it's returning some other managed type, what would it mean to say the runtime thought I didn't fit in that hole, but I totally do, with a type handle instead of an object? That feels like the system's about to burn down.
No, actually, yeah. So it does feel that way. I agree. Basically, what it allows you to do, and we can have the theoretical conversation if this is relevant or not, or we want to do this, but it basically says types can now grow if someone casts for something and they want to permit that operation to happen. This is actually safe. This is only safe because of things like default interfaces, Like we're really leveraging a lot of the new C# language features that allow us to implement this in a safe way. If you notice, and I hope it's obvious, or at least it's mentioned in there, the only type that you can return is an interface type. And the only reason that works is because you can return an interface type because now with default with the default interface feature, an interface can have implementation.
Okay, so effectively this can be used for, you had to do a lot of work, but you made duck typing work?
Yes.
What would happen if you didn't have, like if an interface had an unbound member? Like, is it going to do late binding on the object to find a compatible slot, or is that unstable, or is that a throw? Like, I just want to know if we're adding something that's doing like blind vtable 6 jump.
No, it is not.
So
no, it is not.
Okay.
It is not. So if you look at the in the actual I guess proposal, there was some debate. What is the failure case here? Like, what if someone decides to do something very cheeky and try to trick the system? And we investigated that, and Eleanor, who's actually already has an implementation up and linked against this, was able to mitigate that in a safe way. And basically it'll fall back and say, this doesn't have an implementation for that slot.
So the cast will still fail?
The cast, yes, the cast would fail.
Okay.
Which cast would fail? The cast to bar, or the cast from basically the object to iFoo impl? Sorry, iFoo. Like, where does it be? Yeah, basically where is the failure point here?
The failure point here the failure point here, that the concerning failure point would actually be inside of the call me function.
That's what I thought. Okay.
It would be, that would be where it would be fail. Like everything else, if we just look at this from the, I'm not calling any function, I'm not calling any functions on iFoo when I cast a B to when I cast the bar to a iFoo. At that point, there's really, like, it's all type safe. It is correct. We have the appropriate, I guess, method table for an iFoo. When we dispatch to it, one of two things is going to happen. One, it's going to say, this interface has a default implementation, and it will call it, and will enter the iFoo impl.
Right.
Or B, it will say the iFoo impl does not have a default, has no implementation, therefore I'm going to throw method not implemented.
So I guess my other question is, maybe I'm not seeing it, but it seems like we're going out of our way to make something coupled in a different way, I guess. I mean, how is it different from me implementing iFoo directly on bar? Because it seems bar already has to be aware of iFoo anyways in order to implement this get interface implementation method that knows about iFoo, right? So I still can't extend bar from outside of bar.
So yes, I think conceptually that is the canonical example, because metadata is static. But the example that we're using here is the RCW concept. So instead of calling this bar, let's just assume that it was __ com class, or __ com object in RCW. So I don't know, and all I have that's associated with that __ com object is an int pointer.
I see. You're saying the implementation of get interface implementation isn't actually hardwired to some interface. You have some other mechanism. You look at some other things, and then you know that, oh yeah, there's this other iFoo over there that I'm supporting.
Yes, exactly. This is a completely contrived example. This makes no sense. You're absolutely right. what you would also see, it would basically be if interface type equals whatever, and I've QI'd on some sort of hidden state, and it says, yeah, I do that too. Well, now I can do something.
So that means IFU_impl has to know about bar, but not the other way around, I guess. Yes.
Exactly.
And then, so when you said like perform desired action on the this pointer, I assume C# thinks this is of type IFU_impl, and then I just confirm. I basically just do a hard cast.
Yes. And if you look at the implementation on ifu.callme in the IFU_impl, there you could do any number of things. It's entirely up to you, but your point is taken. This pointer is typed as an IFU_impl, but it is really a bar.
And if I cast it, I'm not causing any recursion problems, right?
If you cast it.
If I just do a normal C-style cast to bar.
Right, because what it will do is it will look at the actual this pointer and say, "Oh, I'm a bar. I'm okay." It's only when all of the built-in casting mechanisms fail.
Okay. Gotcha.
Okay. All right.
I think I understand it now. Yeah.
This is I fully accept that this is a very COM-esque problem. Like it really is. But I think Mr. Fowler actually did ask about this and said, is this something that we could do with dynamically expanding a type? And like theoretically, yes, you could. I don't know if I would advocate for that. That seems like a Pandora's box of you're making a system very complicated. But if there is some value to it, then yeah, you could do that.
I mean, I will say, I can already think of 100 ways how this would be useful. But I mean, to me, the question really is like, what are the boundaries? I mean, people in the chat are kind of asking the same question, and I think last time we talked about this as well. Like, ICastableObject sounds very generic and very appealing, right? And so, how much of this stuff is tied to COM? Like, does it work cross-platform, for example, and does it work with any interfaces, or are there any restrictions that are not outlined here?
No, this is actually like this unblocks an entire COM scenario. Yes, that is true. But it is not bound to COM in any way, shape, or form.
And it works for any interface with no restrictions.
Yeah, no restriction.
Well,
not that I know of.
Any interface that has the castable object implementation attribute on it.
I guess that is true.
Okay, so sorry. let me when
Fair
you
enough.
say any interface, what do you mean by any interface?
I meant modulo the attribute I have to put on the interface. Are there any other restrictions? Like, can I extend any other interfaces, or do they also have to have this attribute on them?
So all right. So the attribute that we're adding is only on the returned default interface implementation, not the actual interface you're casting to.
Oh, because I see. So you basically, yeah, I see. So you basically, yeah, okay, I get it now.
So we're basically saying this interface is a part of some sort of castable scenario, and it needs to adhere to these constraints, and that's almost entirely for the linkability concern.
Yeah. Well, this is really your poor man's version of basically just implementing the interface, right? And you're doing it by extending an interface with an interface and adding a default implementation to it.
Yes, and this would never have worked without default interfaces. Like that is a key feature.
Yeah, that makes sense to me because you need an end-to-end mapping there.
And so, just to complete, I guess maybe for the whole historical thing, .NET Native had two implementations. They had ICastable, and then there was also a castable object implementation. The ICastable did not have any restrictions because at the time there was no way to provide an implementation to an interface in C#. So it basically said, give me any type and I will let you do your job, which was very, very dangerous because you could have fields and you could have all sorts of weird, random problems. There was another implementation, which was CastableObject, which was an abstract base class, and it had a bunch of private state that allowed you to store things, and that allowed you to, again, to cast to any type. in this case, because we have default interfaces, we could very tightly restrict it to saying it has to be an interface type that you return. It has to have this attribute. And we know that it's safe because we're not going to have any field accesses. We're not going to have any of these other problems that a class by definition exposes or can expose.
Right.
Okay.
I mean,
So-
it sounds like pretty much it will work for any interface, right? Because the interface itself doesn't have to be marked, right? So it's only by me providing the implementation for that interface, that's when I have to mark my own implementation for that. But that's pretty much it. So it should literally work for any interface and pretty much any object, so long the object can implement ICastableObject.
Right. So essentially it looks like the interface with CastableObject implementation attribute is using dims and this attribute as making a wrapper class. But don't ask it for complicated things because it's not a wrapper class. It's dynamically interpreting the this pointer.
Yes, that is exactly.
Okay. And so theoretically, this means, like just thinking through experience, if I foo extended I other and someone didn't explicitly register I other as the target, if they went through I foo first, the cast will succeed, and then when it goes to I other, it will explode because it can't figure out how to take that object and turn it into an I other. Because it's a bar, it's not actually the I foo impl. Or is it? Or does it know it's an I foo impl at that point?
Well, where
So if you were I foo interface I foo colon I other.
okay.
So I have a bar and I cast it into I foo and then I cast that into I other, with this being exactly the same as it is right now. Will that second cast succeed, or will it fail because it sees it's a bar, it asks get interface implementation, it says I didn't handle I other, and then it fails?
So where's your I bar? Like it would be, or I other, it's here on this line?
It would it's not in there. He's saying if we had another one, right?
Essentially think of that I foo was an interface in some other assembly and someone added a new base interface to it. We wouldn't do that in the BCL, but let's say it's third party.
Oh, I see.
So what happens? So their get interface implementation explicitly was against IFU's type handle, which is fine. And a cast has already succeeded to IFU. But now if something is turning it into an I other, so like you called a method that took an IFU, it does the dynamic thing, you get this middle interpreted wrapper class, and then it passes that to a method that takes an I other. Does any conversion happen at that point, and does it succeed or fail?
So let me just ask this: the IFU impl implemented IFU. So if IFU extended I other, then IFU impl would have had that information, right?
Right. I'm just curious what state the type system is in at that point.
Oh, I got you. Well, IFU impl would have I other. That's fair, but it wouldn't have any default interfaces for it, so it would say that function isn't implemented.
Right, but let's say it was just a marker interface, and therefore everything just worked. That it had no methods. So I'm just wondering, at the call site, after you get back the I'm cast this to IFU, does the runtime think of it as an IFU when it goes into future casts, or does it think of it as a bar, which wasn't actually an IFU, but things just kind of worked?
Oh gosh, I see what you're saying.
So you have the bar, you pass it into a method that takes an IFU, that passes it into a method that takes an I other. Does everything work? Does something explode in the middle mysteriously?
No, I would have. Okay, I'm more than willing to add. And actually, if Eleanor's on the call. Eleanor, have you validated what that behavior is?
I did try that. So when you first pass it over, it will just say everything works. I am an iBar, but if you actually try to use it for some method that doesn't exist, but to your point of if it's just a marker, I believe it'll just say it's fine.
Okay. I mean, yeah, like the notion of like you get there and there's no method, like that, sure. I'm just curious if the ifoo-ness is a real ifoo or if it's a like as long as you don't squint, or as long as you don't look too closely, we'll just make the syntax work. I guess I'm just curious that we've thought it through. I don't actually super care what the answer is.
Related to that, is there an analyzer that goes along with this to make sure that I's are dotted and T's are crossed so that you don't hit these blow up situations?
Can you elaborate on the blow up situations?
Well, you make a mistake, and there are lots of things you have to do correctly here. You have to be returning an interface. You have to have attributed that interface as a castable object implementation. You have to have provided default implementations of all the base interfaces methods and X and Y and so on. So it seems like it's pretty easy to accidentally not do one of those things, right?
Sure, that's a great question. So of those three that you mentioned, which is the attribute on it and the you must return an interface, those are runtime checks.
Okay.
So if you try to use this, it will blow up immediately. So like, nope, invalid, type has been returned from whatever. So you won't get very far with that. The final one, which I think does probably warrant something, which is we have not checked if the interface that has the attribute has an implementation for all the functions. That is true. Right. But that will blow up. That blows up safely in the sense of you haven't implemented this function. Or yeah, you haven't implemented this function call.
Where does that blow up?
That blows up at the dispatch.
Okay.
Yeah, so at the call to the method that doesn't exist?
Yes.
In our current type loading universe, if somebody adds a method to an interface and the type doesn't have a compatible entry, do we fail to load the type or do we fail to dispatch to the member?
We fail to load the type.
So I wonder if for consistency that check should be here, but maybe you have a performance reason why you can't do it here.
Michal did all the default interfaces. Is there a way to detect enumerate all of the methods on an interface and make sure that at least make sure that everyone has a default implementation?
Yes, yeah, like I propose that even we could do a simpler thing, like we don't even have to go through the default interface resolution logic, because kind of the whole default interface resolution logic also gives you variant casting support and variant interfaces, which like I don't really know whether we want to deal with that. Maybe it's nice, but I don't know. But you can definitely check whether everything has implementations. Kind of when we added default interface methods, we opened the Pandora's box that sometimes you call an interface method and it doesn't actually end up calling anything. And that's kind of in the diamond case scenario. If you have an interface method that is implemented by two different default implementations or more, and kind of when we are trying to do the dispatch, we will throw an exception instead of actually calling something. So kind of that's when we opened up the situation that you might have something typed as an interface, but you cannot call all the methods on it.
Okay. Yeah, I mean, if we have to do it late bound, if we can do it early so it looks more like a type load failure, then that feels like it would be probably more helpful to someone because the failure is closer to where the action happened, which is, like Steve's analyzer suggestion, but also if that helps you at compiling your type, but this is the case where the interface was defined by somebody else, and yes, in the BCL we never add members to them, but if somebody does add a member, what story happens, and can we make that be reasonable? but that's implementation details.
Quick question on this sample: Is there any the visibility on IFU-impl, the public? Is there a reason it has to be public as part of this, or is that just a
No,
that was typed in
no.
the same?
No, I did that because I think in the example, oh, I actually got rid of it. In the example, I had an assert in there that I wanted to demonstrate, but no, it does not have to be public.
Okay, and in fact, it almost never would be, right?
I would, yes, I would agree with that. I don't know why anybody would do that, but
Okay.
they could. Sure.
All right. We can certainly write in the analyzer. We can make the analyzer opinionated and say don't put this attribute on a public interface.
Yeah, I was just more interested in the fact that it was there, whether it had to be public for some reason.
No, it does not.
I think it's also nested, and I feel like you have interfaces as nested types, but maybe I'm just misremembering.
You totally can. You shouldn't, but you totally can. In this case, it makes sense though. If it's a private type.
Fair enough. Yeah. Okay, so on ICastableObject, you have a Boolean parameter throw if not found. I recommend you remove that parameter and let the caller deal with that.
So that function actually does two things. It does the as and the is.
Right, but you can the call context would know which one it is, and it would just know whether default being returned that it should throw.
The call context doesn't know.
Okay. Because of runtime
sort of,
rules.
Well, I mean, excuse me, the call context. The cast. So the implementer basically needs to be told, is it okay to throw, or should I throw a cast, or should I do something else? And it doesn't know. It needs to be told, is this cast operation a part of an is, or is it a part of an as?
Why wouldn't this? Sorry, I missed the beginning of the discussion, but why wouldn't this be a try method and leave all throwing up to the runtime?
Yeah, that's sort of where I'm going with it, but I don't think you could do it without the try, because the default runtime type handle is presumably always invalid. So returning default
just
is
some
that
way of communicating back. Here is the type handle you should use, or I couldn't get one in a non-throwy way.
Because if the implementer is supposed to handle the I'm supposed to throw, that means we'll end up with potentially non-standard exceptions, non-standard messages. They have the boilerplate of if throw throw. All of that feels like the one thing that called this has enough data that it should do it all in a standardized manner, or the two things if one of them's is and one of them's as.
Yeah.
But I guess the question comes down to what stopped it from doing that cast. Like, that's the question here. Like, if we go down the QI standpoint, let's continue down the COM approach, you're on the wrong apartment. Well, the one of the most annoying things in COM is when it says cast failed. It's like, well, the cast really failed, but that's not the problem. The problem is I'm on the wrong thread. And so you never tell me that, and therefore I'm kind of like, well, why did the cast fail? And I spend hours trying to figure out, oh, the cast failed because it's actually on the wrong thread. It had nothing to do with the cast.
So in the RCWs or the CCWs or whatever, some sort of CW, your throw if not found is doing something different than someone would do if they're doing this late bound duck typing for I mean, it's not exactly duck typing, but yeah, they're doing this late bound dynamic cast. They'll end up with very boilerplate looking code, but in the COM layer, you're doing something different.
Yeah, like it depends on how I mean, COM is obviously what we kind of talked about, canonical example. But yes, I think that your point is fair. Let's say you're going down I'm not using COM, I'm just being very cute and I want to add interfaces. I want my object to support every interface, and so I dynamically generate whatever. Yes, I agree with you that in that scenario, it's probably fair. But there is a whole slew of what are we really trying to expose here, and this is the unknown interaction between another system, and a cast is not necessarily the appropriate statement of failure.
So are you hoping that folks will customize the type of the exception that's thrown or the message for the invalid cast exception that's thrown?
I guess it would be. I guess I'm having trouble determining the difference. I think there probably is cases where you may want a very specific exception distinction, or there are cases where no, I'm going to use an argument exception and it's going to have a custom message. I don't.
Right, but is the runtime then going to take that argument exception and wrap it in an invalid cast exception, or is an argument exception going to have appeared literally out of nowhere?
An argument exception is going to appear at that moment.
So like I could say if A is foo, and the implementation could have chosen to introduce an exception at that moment.
Yes, that is true. We would always pass false. Like that would be that's the point of it. But yes, you're absolutely right. You know, people could say, no, I don't care what this bool says. I'm throwing an exception every time. Yes, that is true.
When we're in this path, can we treat it like CC TORs and just always wrap it in an invalid cast exception with context of whatever got thrown, if it's not an invalid cast exception? So casts are still always invalid cast. I mean, it's weird that the is would let any exception leak, but certainly it didn't return true or false, so so it has to throw. But I wonder if letting arbitrary exceptions leak out of this is weird. Like, that feels more like, at that point, it should throw one of the nasty things, like a, I don't know, SEH exception. Like, I'm sorry, someone did something terrible, we're done. We couldn't answer is. So.
Yeah, I mean, I think this, again, I'd have to like look at the performance characteristics of this. I think that at that point, trying to put all that boilerplate around there to handle everything is going to impact that pipeline.
Fair enough.
But I don't know.
I mean, I think this goes also back to what we think the feature is for, right? If you think of this as a interrupt kind of feature, I'm okay with saying don't throw unless throw if not found is true. If it's false and you throw, well, then you have buggy interrupt code. Don't do that. If you throw anything but an invalid cast exception, then you're doing it wrong. You shouldn't do that either. You should always have invalid cast exception and maybe customize the message so that, you know, consumers always get cast exceptions and not some other rando exception. And then that seems fine. But if, I mean, the thing we said last time, which is kind of where I was heading earlier, was ICastableObject seems like both in naming and in the behavior you kind of describe as a, you know, yes, it's interrupty, but it seems like a very useful feature I can see being used more widely than you might want. And so that kind of means maybe we should make it a bit more, you know, I hate to say it, but kind of idiot-proof, where people can't accidentally do the wrong things. Because I'm kind of concerned, like if this is used in some, you know, advanced thing, like for example in our, you know, RCWs, that's fine. But if we use it as a generic feature in, let's say, ASP.NET, for example, then it would be pretty bad if people now get rando behavior because people just implement these methods incorrectly.
Yeah, like it would be very weird if you've, you know, written if A is IFOO and that.
That no longer works the way you expect.
Like,
and it throws argument null exception because that's how we roll.
No, I fully agree.
I mean, there can always be a different version of this in your COM generated thing and the managed objects coming to it. That the managed objects go through more structure and the COM one gets a fast path that you know you're not going to cheat in. So,
I think the important part is to say that these are exceptions that will be thrown from the isInst cast class and unbox and maybe maker, the type reference one. And kind of the exception that these are allowed to throw is specified in the ECMA spec. So kind of throwing something new out of there could potentially break tools, like isInst failing. I'm not sure if like JIT would be able to even handle.
Yeah. So I mean, that would be something else for an analyzer on this is, are you throwing somewhere other than a throw if not found block? Certainly it won't understand throw helpers, but and are you throwing something other than one of the approved exception types? So that'll at least help.
Yeah, like the runtime should ideally not allow the exception to leak out unless it's like one of the allowed ones, which is just the invalid cast exception, really. Like isInst is not allowed to throw.
And so that's sort of the like, if it can just do the like, hey, I called this, wait, and there's a new exception pushed on the stack, and I'm is, like, great, kill the process. Like, we're done. Throw an uncatchable runtime exception. We're done. Someone did a bad thing.
Yeah, I'm not sure that necessarily helps diagnostics, but yeah, it certainly at least doesn't procrastinate the problem.
Tells you to stop writing your bad cast methods.
Yeah,
You
but I
can't
mean,
catch-
but I think this is the problem, right? Like, if you use these things in a more complicated high level, like, I'm not sure the thing now crashes at the right point, right? You might have changed something unrelated, and that causes this thing to misbehave, and then.
That's fair.
I mean, the question is also like, you're taking runtime type handles. Is there any reason you can't take types and return types?
That's an efficiency decision.
I see.
Yeah.
I mean, I'm kind of fine with the behavior you have, but I think we should probably not have a name as catchy as ICastableObject.
Right. I mean, it was the best I've come up with so far is dynamically castable. Because ICastableObject sounds like object. Like, objects can be cast.
I mean, normally I try to make interrupt names better, but now I feel like I kind of want to make it worse so people don't think of this as something that is easy.
iQuery interface.
Ooh.
No. We're not introducing that concept. Oh, please no.
I managed unknown.
Please no.
Or the evergreen I known.
I know.
I maybe.
Yeah, so actually what you said, I maybe, I actually did consider calling it I maybe. And or what is it? What was I also did I am maybe or something like that. It was like I had a bunch of those, other languages have those maybe constructs, and I tried that. I couldn't think of anything, and I chose, we chose ICastableObject because that is what the community knows as the concept from the .NET Native world. The people that are interested in this feature know exactly what this is for.
Yeah, I mean, like that. Yeah, I'm not concerned about those people. I'm more concerned about the casual web developer who thinks it's now a neat way to segregate his interfaces.
Yeah.
And maybe I'm overthinking this because it's still not super convenient to write, but
I mean, I would be very surprised. Here's why I think that this would. I hear the concerns about proliferation of usage. The thing that it comes down to is the implementation of the default interface.
Right.
People are gonna get into there, and they're going to realize the limitations that it does have.
Yeah. So here's what will happen. I can guarantee you is somebody will build a DI-based system that implements this thing once, and uses a DI container to find interface implementations, and then that method will do whatever it does, and it might crash with random exceptions. That will definitely be a case, and that's kind of where my concern is coming from. But I guess like making that name shitty will not stop them from doing that.
Yeah, yes, I agree.
I mean, if you put it in like interrupt services, and we have like already the flow that we have here, we take runtime type handles and stuff. Like it seems certainly interrupt-y in the way you use it, so you should expect interrupt-y style constraints as well. I mean, somebody in chat suggests I call wrapper castable object. I mean, that certainly is meeting my bar for ugly enough. But I guess it still makes sense the way it is here.
Yeah, the name is ICastableObject. It feels like it applies to everything instead of a corner case. The I call wrapper castable object or I dynamically castable at least feel like it's something other than just the normal cast. That this is another thing happening.
If I can, I will put in a vote for the dynamically castable. I like that because it encompasses the concept while also not being completely unspellable.
Yeah. I mean, I did have to look up how many L's were in dynamically, but once you get to idin, then you just hit tab. So we only have to get it right once.
So dynamically castable would be a preferable term, which I think is reasonable.
I mean, I wouldn't mind if having the interface somewhere would be also not too bad, because it's really about interfaces, right? I mean, yes, you have an object implementing it, but what you're really casting to is an interface, right? Always.
Yeah.
Dynamic interface castable.
Yeah, that seems reasonable. Yeah. I mean, that's describing what it does without looking super attractive.
Dynamic interface castable.
Let me type this up because there's no way I can replicate this. Dynamic interface castable. Yeah, as I said earlier, that meets my bar for ugly.
Okay. I think the current proposal put this in compiler services, but it seems more like interop services.
Yeah.
Yeah. This was all of these types. The previous implementations of the ICastable logic was always in compiler services, but moving it seems reasonable.
I mean, this is code we expect people to write manually, right? For the most part.
I'm sorry. Say that.
That is code we expect people to write manually, right? That's not code that's generated anywhere, is it?
Oh no, you would. Well, you would expect a code generator to implement this.
But the normal C# compiler is not going to really ever use this.
That is correct, yes.
Would the compiler need to recognize it if it ever gets the casting support?
What do you mean by the casting support? Because I mean, the idea is you can just cast an arbitrary object instance to an arbitrary interface and the runtime will do the glue, right?
Yeah.
Right, but that requires you to cast to object first.
No.
Oh.
Well, I think it's the compiler right now will warn. I see that there is literally no path where a bar can turn into an IFU. Why are you casting this?
Yeah, if you call through bar, right? As soon as you call through an interface or object, which is the same, the compiler will no longer give you any warnings. Yeah. But I think in practice you will always go through an object or an interface, right? You will never be on a concrete type. Statically, I mean, as far as the compiler is concerned.
Sorry, is that you're saying that the compiler will warn if we try to use this?
So if you have a type called like an actual derived type from object, let's call it bar, right?
Okay.
If the compiler sees bar and you try to call it to an arbitrary other object or an arbitrary other interface, the compiler will first check, is there any interface hierarchy where this can be true? So for example, if bar is sealed and you cast to another type that doesn't derive from bar, the compiler will immediately will give you actually an error and say that cast will never succeed. If you cast to an arbitrary interface and the type is sealed, it will also say, well, sorry, the type is sealed and none of the bases are this interface, so that will never succeed either.
Got it.
So
okay,
but if it's an unsealed type, then
it will say, okay, the interface I don't know.
Yeah, then it'll usually say like, oh, well, this could be anything and the interface could be anything, so I'm just gonna like whatever, I'm gonna let the call happen. So it's only like right after a new where it knows what the concrete type is, or if the type is sealed, that it would be like, there's literally no way this cast can succeed. And you're like, yeah, there is. Go through object.
Got it. So a lot of the implementation or the examples that we've been using have gone through COM wrappers, the COM wrapper API, and that does return an object. So that's why we haven't seen these issues. Okay.
Yeah. But yeah, since all the COM stuff is in system runtime interop services, like, I don't know that the compiler would ever really be able to make use of this because it would essentially need to evaluate the get runtime type handle to figure out what it would have done. So I don't see it ever having language support. So interop services seems good.
I would be very much. I don't want the compiler to participate in this. I think that's kind of our point.
Yeah.
Okay.
I will say I'm thinking about one of the scenarios where this would be used. So one of the scenarios is WinRT, and with WinRT, a lot of the types are sealed, and we would want to have the iDynamic interface castable implementation on on some of those sealed types, so we can do the casts. So that error might come into play because some of those objects are just straight activatable. They can just do new whatever.
Right, but that's the compiler, I guess, could gain support that if something implements iDynamic castable, that it assumes it never has any idea what the cast restrictions are. But I think that would be the extent of compiler features here.
I agree.
We just have to be careful.
agree.
Like, we can't do that later, probably. So if we ship the type now, we can't ask the compiler later to say, "Oh no, everything that implements this interface, please change error behavior." So if you want to do
everything
this,
that uses this interface, stop giving the error on that you can only give in limited circumstances anyway. I think that would be fine.
yeah, I mean, you can try, but my experience is we should at least bring it up with them, because usually if you want to have behavior changed by the presence of some interface or some type, you want to usually do them in conjunction. But
fair.
I mean, yeah, I think that's reasonable. I think if what you said, Jeremy, is true with WinRT, it would be probably helpful to have an example with the compiler team and say, here's the static type declaration, here's the behavior that we want.
Yeah.
And that would be motivating, I guess.
Yeah, so I guess it's try writing it where you have a sealed type in the same assembly, and you write the new and immediately cast it where it will go through this thing. If the compiler produces a warning or an error for that, telling you that it knows that it's not possible, then now you can raise an issue with the compiler team of, hey, this new interface means the runtime will do different things with casting. This means no longer, or you can't produce the warnings anymore. And they'll probably be like, sure.
It's also not too far off the path of the existing COM interop support they have, where they special case things like outs and refs and everything else if you have the COM import attribute.
Yeah.
So a quick, I guess, just to bring it up, because it is COM-esque or is involved in the COM world, is the dynamic keyword. Is there any concern here about since it's iDynamic interface castable or cast, do you have any feeling on, it almost seems like that's related to the dynamic keyword.
I mean, it's sort of related to the dynamic keyword,
but it's not.
It means you don't know, like, magic happens now, and you can't ever predict what it's going to do, and you really, really, really hope it works at runtime. So, maybe in the runtime you have a stronger feeling of what dynamic does, but to me, it's Darby Dragons. So
it's a semantic equivalence in your mind.
Yes, Darby Dragons.
I mean, your notion of dragons and mine are nowhere near the same. I can deal with dynamism, I can't deal with AVs.
I mean, okay, I guess my only concern there would be, this has nothing to do with a dynamic keyword, and I would be very, I don't want people to think that it, like, if you slap dynamic on there, this has anything to do with a dynamic keyword. There's no implementation overlap there. You're not going to get into some performance with dynamic. As a matter of fact, if you use this and dynamic, you're going to get some weird stuff going on.
Yeah, I guess I agree with that. I mean, to me, dynamic is kind of, it's not a very specific feature, right? Because the notion of dynamic behavior is pretty widespread throughout our system. So I wouldn't be too concerned about that.
Okay.
I mean, this would be more, I think, for me, a concern if you would move it to compiler services again, because in the interrupt services, it really is a runtime concept, right? And the compiler service is more like a language compiler kind of concept. And Yeah, in the language world, dynamic has a more specific meaning than in the runtime world, I guess. But I mean, if somebody can think of a different prefix as dynamic, then maybe. But because if you just say interface castable or interface castable and interface castable implementation attribute, that seems also now lost in the noise.
I mean, if I feel like COM uses the verb dispatch, maybe this is more of a dispatch than a cast, and so maybe it's interface dispatchable.
Oh, okay. I'm fine with dynamic. I'm very fine with. I think dynamic is the best word ever. We're gonna go with dynamic.
He's learned to pick his battle.
Oh yeah. As soon as someone says dispatch, no, the conversation is over. I agree with you. Whatever you want.
Wow, I will remember that for next time. Cool. That was easy. So let me just throw up the thing that I have right now. And keep in mind it's on YouTube, so it will probably take 10 seconds for you to see. And there it is, apparently. Someone in chat says, well, we sure hate iDispatch. Well, we don't hate it. It's just really complicated.
I'm fine with dispatch. I just that word is very. That means iDispatch. It means nothing else in my world.
Yeah, I would agree with that. That seems.
That's all. Like I'm fine with iDispatch, but yeah, it's.
Yeah, I mean, it's basically COM's version of dynamic as well, right? So in that sense, it's not really making things much better.
Yeah, I mean, certainly this wins no awards for naming, but as Emo said earlier, that has actually value in that it doesn't win awards for naming.
Yeah, like I think this is a very reasonable API. The naming seems reasonable. I'm glad that everybody seems to be on the same page here.
No, I like the feature. I think it's a good feature.
Yeah. This seems good.
All right, then I will just copy paste this guy into the issue, and then I think we're all happy with this.
Just a quick question, Aaron. Doesn't impact what we were just talking about. I'm just curious at the behavior. So if throw if not found is true, and the implementation doesn't throw, what does the runtime do?
Great question. Then it does fall back and just do the castable has been thrown.
So as an implementer of this, I don't actually have to throw if I don't want to. I can just always return default if I couldn't successfully cast, and the runtime will do the right thing.
That is true.
Okay.
That's worth pointing out then.
Okay. Because that presumably means that for anything other than the COM dispatcher, pretty much it's bool, don't look at this.
I think you could make that argument. Sure.
That the recommended implementation would be just return default and let the runtime throw the standard exception.
Yeah, I don't think that's unreasonable.
But that if you have additional context that you can provide of why the throw failed, or of why you're failing, such as COM, you're in the wrong apartment, then that allows you to handle that case. So that's docs and samples.
Yeah.
And the only other thing beyond docs and samples, maybe, but I don't really care strongly, is we might choose a different name for the parameter, conveying why this is being invoked rather than what action you should take.
Yeah.
I see. The throw side of things?
Yeah.
Yeah, I sort of had the same, like, it'd be nice if this was explaining the mi is or as, but I couldn't come up with a good name for it, so I was uncharacteristically quiet.
I mean, bool is inst would work, right? But it would not be very great, probably.
If you can come up with a better name, Aaron, or
yeah,
Eleanor.
I think that's fair feedback. I think that we can definitely figure that out.
Because then, especially if it moves it to it's sharing what the state is instead of demanding a behavior, then that would go with the hey, if this is the state that represents the actual cast and you return default, we're going to throw the standard exception for you.
I think I think that's good feedback. I think we can apply that pretty easily.
Yeah.
Well, I guess is or as to me it's the
Yeah, I
same
guess
thing.
really it's is it
a cast.
is it as or a hard cast?
Yeah.
Really, but maybe those mean different things in the runtime than they do to the language. Cool. Anything else, Steve?
Ship it.
Why is it not done yet?
It actually, so if you all said it looks great right now, I think Eleanor would just hit merge.
Damn it.
Sorry.
Yeah, so we did mention that there's definitely some room for some analyzers here. Do we feel that that is part of this feature or just a nice to have?
I think given the audience, it's probably nice to have at best.
Okay.
Just because we expect, I mean, how many, can I count on one hand the number of people that are going to implement this in .NET 5?
You might need
Yes.
2, but still, that's still seems very low.
I think 2 of the people are actually on this call, and their names are Tanner and Jeremy.
I actually don't know if I will be using this just because most of my wrappers are currently blittable, and I'm not sure that the RCW is the right way to expose that from my library. I'm still trying to figure that out.
Okay, so we're literally down to one person who's going to be using this feature.
And I might be using this twice, possibly 3 times, depending on if we make a new code generator for a new source generator for COM.
Sure.
Okay, so an analyzer would have value, but the audience is so low that we don't need to commit to it.
Well, we also are planning on, the interop team is planning on putting an analyzer out there, so we can definitely add this to the list.
All right.
Sounds great. Then thanks again. And then for Thursday, we will do the logging thing. Sorry, Miriam. Sorry, David. It didn't happen today.
Well, thank you all. Appreciate it.
Thanks.
Thank you.